Hello, we're going to talk about chapter 4, section 9, which is about the antiderivatives. So first let's review the derivative. We know that when we go back to the derivatives, we know if you take the derivative of x to the nth is going to be n times x to the n minus 1. We call that the power rule of derivatives. For example, if you take the derivative of x squared, you get a 2x. So now, about the antiderivative, we want to know if you are given 2x and you're asked to find a function whose derivative is a 2x. Okay, so you are given 2x and you want to find the function whose derivative is 2x. How do you get it? So we say, you can see you take the derivative of x, so basically the arrow goes from x squared to 2x. So you take the derivative of x squared, it gives you 2x. Now you are given 2x, you want them to go against the derivatives. So you want to find a function whose derivative is a 2x. How do you get that function? So that's the antiderivative, so you're going against the derivative. For instance, in general, when you are asked to find the antiderivative of x to the nth, you will get x to the n plus 1 over n plus 1. So basically you're taking the exponent and you're adding 1 to it, and then you're dividing the new expression by the new exponent, which is n plus 1, as long as this power n is not equals to negative 1. So anytime this power is not negative 1, then you can use this power rule of antiderivative. For example, if you are asked to find the antiderivative of x squared, so you're going to have x raised to 2 plus 1 divided by 2 plus 1, which is x cubed over 3. So the antiderivative of x squared is x cubed over 3. So, but the most general form of the antiderivative is basically we always add a c to it. So the antiderivative of x to the nth power is x raised to n plus 1 divided by n plus 1 and then plus c. C is a constant. Of course, this formula can only be used as long as n is not equals to negative 1. So if n is equals to negative 1, you're going to use a different formula. We will get to it. So let's just play with the antiderivative here. The antiderivative of x, we know, is going to be x squared over 2 and then plus c. The most general form of the antiderivative of x raised to 1 over 2 is going to be x raised to 1 over 2 plus 1, which you give out 3 halves, and divide by 3 halves and then plus c. So if you can also take the antiderivative of negative 2, which is x raised to negative 2, which is x raised to negative 2 plus 1, which gives you negative 1, and then divide by negative 1 plus c. Most of the time, if you have the radical, to find the antiderivative, you must change it to the fractional exponent. For example, the square root of x can be changed as x raised to a half. Then you're trying to find the antiderivative of x raised to 1/2, which is what you already did here. The antiderivative of x to 1/2 is x to 3/2 over 3/2 plus c. Now if your term is of this kind, the cube root of x squared, so you change it to fractional expression, fractional exponent, which is basically x raised to 2 divided by 3, which is x raised to 2/3. Then you find its antiderivative. Basically you add 1 to the exponent and then you divide it by the new exponent, which eventually you're going to get x raised to 5/3 divided by 5 over 3 plus c, But then since you're dividing by a fraction, you can flip and multiply 5/3, which becomes 3/5 times x to 5/3 plus a. You can also find the antiderivative of a sum, which is the sum of antiderivatives. So you will find the antiderivative of x squared, which will give you x cubed over 3. And then this term 1 over x to the 4th, to find its antiderivative, you have to rewrite it as x raised to negative 4 first, before you find its antiderivative. Because to find the antiderivative, you need x raised to the nth power. So x must be of the term. You have to use the power rule of antiderivative. So x must be raised to the nth power. There's no fraction here. It's x raised to an exponent. So if the term doesn't look like this, you have to make sure it looks like this before you find its most general form of the antiderivative. So that's why when you're trying to find the antiderivative of 1 over x to the 4th, you have to change it to x raised to negative 4 first, and then you can find the antiderivative of this by adding 1. So negative 4 plus 1 is negative 3 divided by negative 3. So when you're done, then you put plus c. So we continue with this. So then we go to what we call trigonometric function. So let's just explore the derivatives. We know the derivative of sine x is cosine x. So now, so you go from sine x to cosine x by taking the derivative. What about if you are given cosine x? They want you to find a function whose derivative is cosine x. So you're looking for sine x here. So what is the antiderivative of cosine x? Now, so we know since the derivative of sine x is cosine x, so the antiderivative of cosine x is sine x plus c. Because when you take, the reason is we want to be able to take the derivative of sine x plus c to get cosine x. Now when you take the derivative of sine x, it gives you cosine x. Since c is a constant, the derivative of c is 0. So you end up with cosine x. So again, the antiderivative of x is x squared over 2 plus c, because the derivative of x squared over 2 plus c is x. You can see when you take the derivative of x squared, you get a 2x, divided by 2, it gives you x. So the derivative of cosine x is negative sine x. So that you could be asked to find the antiderivative of sine x. So you're going to say the antiderivative of sine x is negative cosine x plus c. Why? Because the derivative of negative cosine x plus c is a sine x. When you take the derivative of cosine, it gives you negative sine. Negative and negative makes it positive sine x. Derivative of a constant is 0, so you get that sine x. Okay, so then you have the table of the derivative and antiderivative. So basically we're looking at here, the antiderivative of x to the nth is x to the n plus 1 over n plus 1, as long as n is not negative 1. Now, so you have, we did antiderivative of cosine is sine x plus c. Antiderivative of sine x is negative cosine x plus c. Antiderivative of secant square x is tangent x plus c. Antiderivative of cosecant square x is negative cotangent x plus c. Antiderivative of secant x tangent x is secant x plus c. Antiderivative of cosecant x times cotangent x is negative cosecant x plus c. The antiderivative of 1 over square root of 1 minus x squared is arc sine of x plus c, and so forth. You are given all these antiderivatives of these functions. So remember, we are looking at column 3 and column 4 because we're talking about the antiderivative. So so here an example. So you have, it says find the most general form of the antiderivative. So you are given this function. Usually when we find the antiderivative, we write of small f of x, we call it uppercase f of x. So we know the antiderivative of secant x tangent x is just secant x minus the antiderivative of x squared is x cubed over 3, and then the antiderivative of sine x is negative cosine x. So when I'm done taking the antiderivative of every term, and then I put plus a. So most of the time you will be asked to, so they give us here, with this example, they give us the second derivative of the function f of x, and then equals to 6x plus 12x squared. They want to us to find the function f from f double prime. So the steps are, we're going to go from f double prime to f prime and then to f. So we cannot go directly from f double prime to f. So therefore, we're going to take the antiderivative of f double prime, which is going to give us f prime. And then when we take the antiderivative of f prime, it gives us f. So let's do it. So we start with f double prime of x is 6x plus 12x squared. We find its antiderivative, which is give us f prime of x. And then we go find the antiderivative of each term. The antiderivative of 6x is then 6x squared over 2 plus the antiderivative of 12x squared is 12x cubed over 3 plus c. So we do some simplification. 6 divided by 2, it gives us 3, and then 12 divided by 3 gives us 4. So we have f prime of x, which is a 3x squared plus 4x cubed plus c. And then since we want to find f, we then take the antiderivative of f prime of x. So we know the antiderivative of f prime of x is f of x. And then to the right side, we take the antiderivative of a 3x squared, which is a 3x cubed over 3, plus the antiderivative of 4x cubed is a 4x raised to the 4th power divided by 4, and then plus the antiderivative of c is a cx, and then plus d, the new constant. So after simplification of 3 and 4, we get our function f of x, which is x cubed plus x to the 4th plus cx plus d. That's the function we're looking for. Okay, so I'm going to stop here because we don't want the long video. Thank you for watching.